In my today's lecture, I want to describe the solar energy storage system. The solar thermal energy storage systems can be classified as the sensible heat storage, the latent heat storage, the chemical thermal energy storage, the plastic crystal thermal energy storage, and the solar battery storage. The thermal energy storage can basically be classified according to the way heat is stored as sensible heat in hot liquids and solids, as latent heat in melts and vapor, and as chemical heat in chemical compounds. Heat in the physical sense is a form of energy and can be stored in a variety of ways and for many different applications. A characteristic property of heat is its temperature. According to this, it can be distinguished in low temperature heat and high temperature heat. The former is usually applied for the domestic hot water supply. It is usually stored in small hot water tanks when used for single family houses, or in large underground containers for large housing projects with 100 and more apartments. The high temperature heat is applied for all sorts of power processes and in chemical engineering. In these cases, the heavily insulated tanks, often pressurized, will be used. There is another criterion for the thermal storage depending on the time involved, that is short-term storage for a couple of days or the long-term storage over a period of months. This is also called the seasonal storage. The criteria for low and high temperature heat are not specified. Usually the temperatures below 100 degrees centigrade are named as the low temperature, and the above of 100 degrees centigrade, it is called the high temperature. Now come to the first type of heat storage, thermal heat storage, that is called the sensible heat storage. The thermal energy may be stored as sensible heat or the latent heat. The sensible heat storage systems utilize the heat capacity and the change in temperature of the material during the process of charging or the discharging. Temperature of the storage material rises when the energy is absorbed and drops when the energy is withdrawn. One of the most attractive features of the sensible heat storage system is that the charging and discharging operations can be expected to be completely reversible for an unlimited number of cycles, such that over the lifespan of the storage. The use of sensible heat energy storage materials is the easiest method of the storage. In practice, the water, sand, gravel, soil, etc. can be considered as the material for the energy storage system, in which the largest heat capacity of water, so the water is used more often. The schematic of various concept of stores for the sensible heat is shown in the figure. The water displacement store has a volume of some 100 liters and is used for hot water supply in house. Secondly is the pebble or the water pit, that is called the pebble, and the water reservoir is for the seasonal storage of heat. It is sometimes named as the man-made aquifer and comes in size of up to the 10 meter cube. The Cowper regenerator is the device used in steel and the foundry industry for many years. Now the solar pond. The solar pond is a special arrangement for an easy store of solar heat. This heat is absorbed at the bottom of the pond and heats the brine there. The salt concentration in the pond increases from the top to bottom so that the density increases and the natural convection is suppressed. because of its simple, low cost, and it is suited to large scale applied, so that it has attracted the people's attention. Now the schematic various concept of the stores for the sensible heat is shown in the figure. First is the ground store, multiple well stores, aquifers, and the storage reservoirs as the seasonal stores, which are supposed to transfer the summer heat into the winter demand. The Ruth accumulator stores the hot water under high pressure. When the discharge valve is opened, the pressure is released and the superheated water will evaporate until the equilibrium at the corresponding saturation temperature is reached. The water cools down since it provides the evaporation heat to the steam. The effective store depends very much on the store material. The following requirements should be met: the long service life, non-corrosive, non-toxic, and the non-flammable, that is called the large heat storage capacity. Second is the high thermal diffusivity. Third one is the capability to withstand the charging discharging cycles without loss in performance, store capacity, or the change in structure. Fourth one is the wide availability, simple handling, storage in simple containers. And last is the low cost. Now come to the second type of storage system, that is called the latent heat storage system. It is generally the accepted that the cost effective storage is the key to a high penetration of renewable energy in electricity grid. The latent heat thermal energy storage, that is LTES or the LHTES, the stores energy by converting the storage material from one state to another, typically the solid to liquid. This is the solid to liquid phase and this is the liquid to solid phase. From the left side to the right side, this is the solid to liquid phase, and from the right side to the left side, this is the liquid to solid state. The materials used in the LTES are commonly referred to as the phase change material. The phase change means the solid to liquid and the liquid to solid phase. The application of the phase change materials for solar thermal energy storage capacities has received the considerable attention in the recent years due to their large storage capacity and the isothermal nature of the storage process. Commonly, the salt crystal is used in the low temperature storage, such as the sodium sulfate dehydrate or the calcium chloride, sodium hydrogen phosphate, 12 water. However, we must solve the cooling and the layering issues in order to ensure the operating temperatures and the service life. Medium solar storage temperature is generally the higher than 100 degrees centigrade, but under the 500 degrees centigrade. Usually it is around 300 degrees centigrade. Suitable for medium temperature storage of the materials are the high pressure, hot water, organic fluids, eutectic salt. Solar heat storage temperature is generally above the 500 degrees centigrade. The materials currently being tested are the metal sodium and the molten salt. Extremely high temperature above 1000 degrees centigrade storage, the fire resistant ball alumina and the germanium oxide can be used. As the heat is added, the temperature increases until the phase change point is reached, where the temperature remains constant until all the materials has melted, as shown in the figure. Significant heat is added at a constant temperature during this state. The range of temperature control from here to here. Now the heat transfer fluid is separated from the PCM material, phase change material, and is transported through the storage by a variety of heat pipe designs. Figure shows a typical PCM based solar power system. Most systems use the stored heat to develop the steam for the power turbines. Heat is transferred from the solar collector to the PCM storage unit via a heat transfer medium, which is usually thermal well or molten salt. Although the high temperature systems have been developed that use the molten metal alloys as the heat transfer medium. The HTF passes through the vent pipes in the PCM store in both the heat transfer and the heat recovery mode in the figure. The PCM material is retained at the phase change temperature. Now the latent heat storage has the two main advantages. One is it is possible to store the large amounts of heat with only the small temperature changes, and therefore to have a high storage density. Because the change of the phase takes place at a constant temperature, it is possible to smooth out the temperature variations. Now come to the third type of storage system, that is chemical thermal energy storage. The thermal energy storage is making the use of the chemical reaction to store the heat. It has the advantages of the large amount in heat, small in volume, light in weight. The product of chemical reaction can be stored separately for a long time. It occurs the exothermic reaction when it is needed. It has to meet the needs of the below conditions to use the chemical reaction in the heat. One is the good in reaction reversibility, no secondary reaction, rapid reaction, easy to separate the resultant and the reserve it stably. Reactant and the resultants are innoxious, uninflammable, large in heat of reaction, and low price of the reactant. Now some of the chemical endothermic reaction could be made the needs of the above conditions, like pyrolysis reactions of the calcium hydroxide using the above endothermic reaction to store heat and release the heat when it is necessary. But the dehydration reaction temperature in high atmospheric pressure is higher than 500 degrees centigrade. It is difficult to use the solar energy to complete the dehydration reaction, so we can use the catalyst to decrease the reaction temperature, but still very high it is. So it is still in testing time for the heat of the 14 reserve in chemistry, heat 14. Now the fourth type of storage is the plastic crystal thermal energy storage. In 1984, the US market launched this type of plastic crystal materials for the home heating. Plastic crystal scientific name is the neopentyl glycol, NPG. It and the liquid crystal are similar to the three-dimensional periodic crystal, but the mechanical properties are like the plastic. So it can store and release the thermal energy in the constant temperature, but not to rely on the solid liquid phase change to store the thermal energy. It stores the energy through the plastic crystalline molecular structure occurring the solid to solid phase change. When the plastic crystals are at constant temperature 44 degrees centigrade, it absorbs the solar energy and stores the heat during the day and releases the heat during the night. Now the last type of storage, this is very important storage of the solar energy, that is the solar battery. a device that reserves the energy for the later consumption that is charged by a connected solar system. The stored electricity is consumed after sundown during the energy demands peak or during a power outage. Most common on the residential or the commercial buildings. Before going to make a solar battery storage, we should consider the conditions under which the battery must work and the types of the batteries that are on the market available today. Understand the power needs of the home to choose the right battery option. Now the batteries and the solar systems work together to effectively manage the several conditions like the unstable grid energy. The many utility companies have blackouts or unforeseen power surges that zap our neighborhood of energy. Our solar battery should kick in and run power to our home so the lights stay on and we stay connected to the community. Second is the heavy cycling. Our solar battery will charge and discharge during use. The term charge cycle is used to specify a battery's expected life. The number of cycles affects how long it will last as time goes on. Third one is the irregular full recharging. What happens to our solar system if the battery is not fully charged on a consistent basis? We need to count on using its backup energy when we need it. Make sure our battery works for us and delivers power to our home when we need it. There are the three types of common batteries available in the market. One is the lead acid type battery. This older battery technology has been used in renewable energy for a long time. These batteries could be a good option for the homeowners who want to go off the grid and are relatively low in the cost. Off the grid is for the homeowners who cannot rely on a local utility. We will discuss the battery as a fuel cell in the subsequent lectures. The lithium ion battery, this is the second type of battery which are used as a battery storage system of the solar energy. The most homeowners want to and need to stay connected to the grid, so the current research report indicates that the lithium ion battery is dominating the market as shown in the figure. Although a bit more expensive, it is most popular battery for the homeowners due to its superior performance and the reliability with our local grid than the other batteries. Third one is the flow. This type of battery is the newest option for the solar storage. They don't degrade over time, so they can last much longer than the other types of batteries. But its complex chemistry often requires the additional energy and the cost, which is shown in the figure. This battery could be a good option in the future, but currently the lithium ion is the clear winner in the market. These are the references from where I take the materials and build my lecture. Please go through these references, then you will get all the information related to this.